So as discussed, the optimal thing for us to do in the priority queue problem is, well, let's heapify what we have. So we had this list of priorities, for example, 19, 21, 16, something like that. Clearly, this is not a heap, but with an one-time order of an effort, I can heapify this and convert this into a min heap. Now notice when I've done this, basically these items have moved around, and 3, which is the lowest score right now, so highest priority, has ended up on the root 358. Clearly a heap structure is being created, a min heap has been created. We can see it very, very clearly from here. Every parent is smaller than its children. But notice significantly that the list is not sorted, because heapification, as we have discussed before, is indeed not the same as sorting. Nonetheless, the most, let's say, highest priority customer has still been brought up to the top. So basically, when we have to find the minimum, all I need to do is to just read out this. We'll see later what happens when we actually extract this guy, but that's for later. But you can clearly see for now that with reading the first item, I would have got the minimum, which is what I was looking for. Now, obviously, this was true also if I had done a sorting. So I could have gone from, being a heap, which is not a fully sorted list, to a completely sorted list. But then heap is better, because all I wanted is the smallest item, right? I don't really care how these are arranged, so long as there's a structure in there which we can use later on. So basically, sorting and so sorting is basically too much work for this problem. Now, obviously, if we had left the list unsorted, well, we would have to look at all the items of the list to sort of, do find the minimum, which you can argue for the first time is the same as creating a heap, because remember, heap is also order of n. But then the question is, we have to do this again and again, again and again, and that's where heap starts to win, right? So think about it. We'll develop this solution a bit more in the coming videos. For example, what happens when a new patient comes in? What happens when the patient at the top of the list leaves? Or what happens if some other patient? We'll realize that in all of those situations, yes, there'll be a temporary disruption to the heap structure, but that structure can be restored back in an order of log of n events, and which is why heapification is a great thing to have been done for this problem. I hope you found this interesting. Do look at our website www.ybyte.in for more such videos, and enjoy programming. Take care. Thank you so much. Bye bye.